We've talked about photons as the smallest particle of light. And we've said when you get down to the photon level, if you split that photon further, it loses the properties of that light. And indeed, splitting a blue photon into other photons is possible, but it no longer has the properties of the blue light that it originally had. It's the smallest particle of blue light that you could have, but splitting it is still possible. So let's talk about that. A photon at 400 nanometers is split into two. One of the photons that comes out is at 1200 nanometers. What is the wavelength of the other photon? So let's consider that. Is it A, 200 nanometers, B, 600, or C, 800 nanometers? What is that other photon? Think about that for a minute and make your selection. Let's consider an argument for each of the answers. A, splitting a photon must reduce the wavelength, and 200 is the only smaller wavelength. B, energy is conserved, and it's inversely proportional to wavelength. So 1 over 400 equals 1 over 600 plus 1 over 1200. Or C, the sum of the wavelengths must be conserved and add to the longest wavelength. So 1200 is 400 plus 800. Consider those three arguments and make a selection again. When we split a photon into two other photons, the total energy that we start with can't be lost. So energy will be conserved. So the two smaller photon energies must add to the original photon energy. And photon energies add as the inverse of the wavelength. So indeed, hc over 400 must equal hc over 1200 plus the other photon emitted, and that must be hc over 600. So indeed, two lower energy photons add to give the high energy photon, and the correct answer here is B, a 600 nanometer photon is split along with a 1200 nanometer photon when you split that 400 nanometer photon.